On my last video on Ohm's law, I talked about how Ohm's law became famous partially when a man named Charles Wheatstone said how Ohm's law helped him create what is now called the Wheatstone Bridge in 1843. I then found out that Wheatstone's bridge was actually invented 10 years earlier, Wheatstone, by a man named Samuel Christie, something that Wheatstone admitted in his paper. This caused my spidey sense to tingle. Why did Christie invent the bridge, and why did Wheatstone get it named after him? After looking into it, I found that Wheatstone often skirted on the edge of dishonorable behavior and sometimes went into outright villainy. Did he deserve to have it named after him? Well, sort of. Ready for the story? Let's go!
Electricity, 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 electricity.
I'd like to begin in August of 1831, when Michael Faraday published his astonishing discovery that changing the magnetic field in the coil of wire would induce current in that coil. This was big news in the scientific community, and Faraday was awarded the Royal Society of London's highest award, the Copley Medal, for his discovery of magnetoelectricity. Now we turn to a mathematician and member of the Royal Society named Samuel Hunter Christie. Christie was friendly with Faraday and had actually been with Faraday and seen him do some of these amazing experiments, and felt very strongly that Faraday deserved all the accolades that he was receiving. However, Faraday had written in 1831 that induction in copper coils was the same as induction in iron coils, and that was something that Christie said he had, quote, a great difficulty in adopting. It was for that reason that in 1833, Christie started to do a set of delicate experiments to either validate or refute Faraday's claim. The first idea Christie had was to wind insulated copper wire in one direction around the cylinder, and then wind insulated iron wire the opposite direction, and then connect the two wires and measure with a compass if the copper or the iron had more current in it. To which he found that, quote, the intensity of the current from the iron wire was less than half of that from copper. Now I have to admit that even though this was over 6 years after Ohm had published his book about Ohm's law wasn't well known in England or even widely known in Germany. So neither Christie nor Faraday had any idea about the difference between voltage and current. Christie then tried to balance the two induced currents by using less loops of copper wire and more loops of iron, but then wondered about the relationship between the length of wire and the current induced. Remember, this was before they knew about Ohm's law. So then he tried it with only one kind of material being induced, but then having the current go through crisscross wires, where he varied the length and the thickness of the iron to make it match the copper, by bridging the wires with another wire and adjusting the iron until the current in the bridge was zero. This was the first example of Wheatstone's bridge. However, Christie's paper was very long and convoluted and didn't have much of a conclusion, so it wasn't well known outside of England. Now we go to the year after Christie's talk, 1834. That was when a 32-year-old Charles Wheatstone displayed a new method to measure the speed of electricity in a wire by looking at a spark in the beginning, the middle, and the end of a long path with a spinning mirror. At the time, they thought electricity was instantaneous and were shocked to learn that electricity moves at a set speed depending on the conductor. We now know that there was something wrong with this experiment, as Wheatstone discovered a speed that was faster than the speed of light. But at the time, his experiment was roundly praised, and Wheatstone was suddenly considered one of England's top scientists. By January 1836, Wheatstone was elected as a member of the Royal Society of London and became close friends with the secretary of the Royal Society named Peter Roget. That was why in February of the following year, 1837, when Roget was visited by a newly retired soldier named William Cooke about an electric telegraph system, Roget recommended that Cooke go and see Wheatstone. Cooke was delighted to find that Wheatstone had 4 miles of wire ready for experiment, but was dismayed to discover that Wheatstone was also working on telegraphs and had even built 2 or 3. They quickly decided to collaborate, as Cook wanted to work with a man who had invented a method of, quote, ascertaining the velocity of lightning. By June 12, 1837, Cook and Wheatstone filed for their first patent for a telegraph that used 5 wires and a diamond shape where 2 of the compasses would point to a specific letter to spell the code. For example, this would be for the letter B. At first they worked well together, but then Cook quickly became frustrated that, as a biographer of Cook put it, the glory of Wheatstone's name and reputation at once overshadowed and eclipsed that of Mr. Cook. Cook tried to work it out with Wheatstone, but then soon found that he felt that Wheatstone wasn't only not countering these statements, he was the source of these statements, complaining, quote, the invention at once became a subject of public interest, and I found that Mr. Wheatstone was talking about it everywhere in the first person singular. Now we move to a man whose important influence has really been lost to time. His name is Moritz Jacoby. Jacoby was a Russian Jewish man who was born in Germany and initially became an architect. Jacoby had many skills, and in the early 1830s he read about some crude motors and decided to build one of his own. In this quest, Jacoby read the 1827 book by Ohm and declared, quote, the theory established by Mr. Ohm offers so much simplicity and agrees so well with all the phenomena of the voltaic pile, I have not hesitated to adopt it. Jacoby, remember, was born in Germany and spoke German, and Ohm was German and his book was in German. With the help of Ohm's equation, in 1834, Jacoby constructed the first practical electric motor, which he published in Germany and then in France. Jacoby's motor remained the world's most powerful electric motor until September of 1838, when Jacoby invented an even better motor. It wasn't until the 1840s that anyone caught up to him. Meanwhile, in 1837, Jacoby moved to St. Petersburg and, with the help of Tsar Nicholas, focused on his electricity studies, although he still also worked as an architect. In October of 1838, Jacoby realized that his electrical processes would leave deposits of copper and invented electroplating, and then used this process to make some copper copies of medallions. It was doing these experiments that inspired Jacoby to invent a method to control the current by varying the resistance, which he presented to the Academy of Sciences in St. Petersburg in March of 1839. In August 1840, Jacoby went to London and visited Charles Wheatstone, whereupon Jacoby was startled to see Wheatstone demonstrate his machines to control the current by varying the resistance. Jacoby felt that Wheatstone's devices were, quote, founded on exactly the same principle as mine, and with very inconsiderable modifications and differences. Unfortunately, I can't find any images of Jacoby's original device or devices, but I do know that in 1840, Wheatstone told Jacoby that they had come up with the same idea independently, which Jacoby thought was, quote, quite impossible. However, Jacoby was mollified when Wheatstone told him that he was not only using this device to control the current, but also as a way of measuring the resistance. Although Jacoby thought that Wheatstone, quote, has shown me in his unpublished papers very valuable results which he has obtained with this method, Wheatstone did not publish his method of using a variable resistor to measure an unknown resistor for a further 3 years. Why not? Well, what might have been the delay is the very same month he got called out by Jacoby for coming up with the same idea for a variable resistor. Wheatstone was visited by a young clockmaker named Alexander Bain, who demonstrated an electric clock and some electric telegraph equipment that would print out the signal. According to Bain, Wheatstone promised to purchase the telegraph equipment, but told him the electric clock was worthless. Then, 3 months later, Wheatstone published his electric clock and stopped payments on the telegraph equipment. Bain fought against this as best he could, and in 1843, a friend of Bain's published a book about how Bain was the inventor of these items, which put Wheatstone in the middle of that controversy. At the same time, Wheatstone was supposed to give a very important lecture called the Bakerian Lecture, and no, I'm not sure I pronounced that right, for the Royal Society of London. It might have been for that reason or for some other reason that I cannot figure out, but that in June of 1843, Wheatstone introduced his bridge with his resistance meters with Ohm's law to help him. Now we finally get to Wheatstone's bridge, which was designed to accurately measure resistance. The current is split into two different paths where, quote, the equilibrium having been disturbed by the introduction of a resistance in one of the wires may be restored by placing equal resistance in either of the adjacent wires. In other words, Wheatstone was suggesting that you could determine the resistance of an unknown system by comparing it to a known resistor and then adjusting the known resistor until no current flowed in the bridge between the two paths. Note that neither Wheatstone nor Christie used the term bridge. Although I don't know any of the details of Jacoby's variable resistors, I do know the details of Wheatstone's, of which he had two. The first one was where he spun a handle to move wire from a non-insulated cylinder into an insulated cylinder, so that the current only went through the wire of the insulated cylinder, and thus the length of the resistor is varied. The second method is to use a large cylinder where a moving connector would change the length of the resistor. Wheatstone called both of these devices rheostats, a name that was used for many years and is sometimes still in use today for a variable resistor that is used to control the current. In other words, Wheatstone was describing using a rheostat invented by Jacoby in 1839 with Jacoby's description of Ohm's law that was written in 1834 and translated into English in 1838, and a Christie bridge from 1833. Now, combining other people's idea is a major accomplishment, but it's important to acknowledge everyone else's contribution in an honest way. So let's go over how well, or not so well, Wheatstone did with this. The rheostat. In his original paper, Wheatstone did add a footnote from Jacoby's talk in 1840, where Jacoby had stated that he had previously invented these variable resistors, but only used them for controlling the current, not measuring the resistance. Although Wheatstone said that his device was far easier to use, saying Jacoby's devices differs in mechanical construction from either of mine and is less convenient to manipulate, without any details as to why. After this talk, Wheatstone was memorialized as the originator of the name, and often the originator of the rheostat itself. As far as I can tell, that's because Jacoby didn't give his device a name. It's impossible to find Jacoby's pictures, although people in the 1800s knew of it. And also, Wheatstone was so famous from this talk and from other things that it obscured Jacoby's influence. Promoting Ohm's law. As I said before, Jacoby had been promoting Ohm's law since 1834, and it had been translated in English into 1838. However, Wheatstone had also been promoting Ohm's law since about 1840, around the time when he started using Jacoby's rheostat to measure resistance. But Wheatstone continually failed to mention how he learned about Ohm from Jacoby. But in his 1843 talk, Wheatstone continued to imply that most people didn't understand Ohm's law, and therefore he needed to teach everyone about it. So that because this talk was so popular, that in retrospect, it seemed like Wheatstone was the one person to teach England and then the world about the usefulness of Ohm's law. The bridge. Wheatstone's original paper and talk had no mention of Christie or a bridge. And the original preprints that were sent out also had no mention of this. However, someone must have complained, because by the time it was formally printed up, it contained a footnote that said, Mr. Christie has described a differential arrangement of which the principle is the same as that on which the instruments described in this section have been devised. To Mr. Christie must, therefore, be attributed the first idea of this useful and accurate method of measuring resistances. However, after this footnote was added, Wheatstone had his paper translated into French and German without the footnote. Meanwhile, Wheatstone's influence continued to grow. In January 1845, a year and a half after Wheatstone's talk, a Quaker man named John Tawell killed his mistress and a person of his description had been found to have purchased a train ticket to London. The police then used the newly installed Cook-Wheatstone telegraph to warn the police to look out for him. And amusingly, telegraphing Quaker as K-W-A-K-E-R, as there is no Q in their telegraph. Towell was arrested and then in March hanged for his crime. This, the first capture of a murderer by telegraph, made everyone really interested in telegraphs and made Charles Wheatstone's reputation skyrocket. By September 2nd, 1845, one of the world's first public electric telegraph companies was formed, called the Electric Telegraph Company, and Wheatstone received £30,000, equivalent to around $5.5 million today, for his contributions, and was hired as a technical advisor. However, according to Cook, when they tried to incorporate the company the following year, Alexander Bain, remember him? He filed a petition that Wheatstone had stolen his electric clock and electric printing telegraph, and a member of the House of Lords decided that Bain's position had so much merit that the company had to pay him off, which they did, as well as hiring Bain. The company also hired a man named Henry Maple, who also claimed that Wheatstone stole from him, and Wheatstone quit the company in a huff. Despite this, Wheatstone was still often known as the sole inventor of the telegraph, and he was asked to be part of a committee to work on sending telegraphs under the ocean floor between England and the United States in 1859. Then, in 1860, a German engineer and co-founder of the Siemens Company, who was then working on telegraphs in Germany, named Werner Siemens, wrote an article about using columns of mercury as a standard measure of resistance, as he felt the standards created by Jacoby in 1839 were inconsistent. Jacoby's standard resistances, by the way, from 1839 were a set length of copper of a certain weight, and Wheatstone's from 1843 were a set length of copper of a certain length. Anyway, in this paper, Siemens wrote about using what he called Wheatstone's Bridge to measure the resistances. As Siemens was German, he probably didn't even know about Christie. As far as I can tell, this paper, which was translated into English like a month later, is the first instance of using the term Wheatstone Bridge or Wheatstone's Bridge. And Siemens' younger brother, who'd moved to England, had also used this term in the following weeks. Although Siemens' idea of using a column of mercury as a standard resistor was eventually dropped for defining 1 ohm as 1 volt over 1 amp, Siemens' article made Wheatstone Bridge popular both as a name and as a device. In June 1861, a Scottish scientist named William Thomson, later knighted Lord Kelvin, like the temperature, wrote about his new bridge or balance to measure very small resistances. He skipped over Jacoby and Christie entirely and stated that, quote, "The beautiful arrangement was first invented by Professor Wheatstone and is frequently called the Wheatstone's Bridge, especially by German writers, although Thomson preferred the term Wheatstone's balance." In the 19th century, scientists used the Wheatstone Bridge basically in the same way that Wheatstone and Christie did, by adjusting the resistance of a rheostat until the two branches are balanced. However, by the 20th century, many people started using bridges with 3 constant known resistors, and then using the difference in voltage to get the unknown resistor. In addition, sometimes teachers like to give a Wheatstone Bridge problem where it's just set up so you can't solve it simply as a series problem or a parallel resistor problem, although as far as I can tell, no one actually solves the problem this way. But we like giving challenging problems, so sometimes that happens. That was the history of the Wheatstone Bridge, why it got its name, and why it was named after Charles Wheatstone. I honestly think he deserved it to be named after him because he did do it in a different way than Christie did, with knowledge of Ohm's law. But boy, oh boy, did he skirt on the outside of dishonorable behavior. And I didn't even include half of it. Okay, I next want to talk about a scientist who was also influenced by Jacoby to study Ohm's law and who ended up changing the world with it. And his name is James Prescott Joule. And that's next time on the Lightning Tamers. Thanks for watching my video. If you haven't seen my video about Ohm, you should check it out. If you haven't seen my videos about Faraday, you should definitely check it out. I love Faraday. Also, thank you to my Patreons for putting up with me and supporting me. Thank you, patrons. If you want to be thanked as well, there's a link down below. Thanks so much. Have a good day. Stay safe. Bye. Always give kudos to people for what they did. It's important, because otherwise you may get famous and knighted. And yeah, he had a good life. Bye. And